Hello! Today we are going to have a look at a couple of Snell and Wilcox Mach1 television standards converters. Now these things, like most of the stuff that I look at on this channel, are pretty well obsolete by today's standards. Now in terms of what they would have actually done back in the day, a conversion between a 525 line and a 625 line digital feed is the most likely application. Now that having been said, they do have a number of analog connections on them, so they were also useful in the transition from analog to digital, and certainly if you wanted to convert from SDI to analog or vice versa, then certainly in my opinion they're a much nicer way of doing it than these things here, which I'm not really a particular fan of. Now in terms of the positioning of this product, it was a relatively entry-level standards converter product from the company. And it's not the sort of thing that you would have been running the US Open through, certainly not unless you want to receive a whole bunch of letters from viewers, and yeah, you don't really want that. And Snell and Wilcox did actually have much higher end standards converters for those really high profile things. But yeah, for a feed where there's not such a high expectation for quality, an item like these, yeah, definitely, that's the kind of thing that it would be used for. Now, first thing we're going to do is have a look and see what the faults of these units are and see what realistic prospect there is of repairing them. Now, these things are quite digital and quite scary and quite complicated, so I'm not really sure if this is going to be a nice easy fix or if this is going to be a real nightmare and going to drag on for a long time. And if it does, what I'll probably end up doing is splitting this video into two. So we'll have a second part where the actual demonstrations are, and hopefully not a third part, because I don't want to spend that much time on these things if I can avoid it. So let's get into it. Now we are rather lucky here to have two samples of the same piece of equipment which both have different problems. Now I know they do look a bit different, but if you look close in the details, they are the same thing, they're just different versions of it. So I think this one here is probably a little bit older. Now the descriptions of the faults that I've been given is that this top older unit here, some of the buttons on this panel don't work, which yeah, that sounds like potentially a fairly easy problem to fix. And this bottom unit is a bit more, this is a bit more interesting. Now it sometimes occasionally doesn't boot up. Now some weeks ago I switched this one on and had a play with it, and it wasn't really clear which buttons were supposed to be working or not working, because I don't know really how these things, what interacting with these things are supposed to be like. So what my plan was is that maybe we'll try and get this one up and running first and then compare the two, and then I can maybe work out which buttons are not actually working. So we'll skip this one for the time being and focus our attention on this one here. So yeah, let's just power it on and see what actually happens. So searching for units, please wait. So this is a bit of a strange looking message which has been on the screen for quite a long time now, so I think it's safe to say that it hasn't successfully booted up. Now there is actually a section in the documentation which gives us some clues about how these things actually work internally, so let's go and have a look at that first. So in this diagram here, we have a little bit of information about how this thing is actually working internally, particularly around this front panel. So what we can see here is that the front panel is shown as being a separate item to the Mach1 electronics, which I'm going to call the baseboard. And there's this roll call gateway card, which is some sort of switching and interface item. So what I think is happening here, or what's possibly happening, is that this baseboard is not booting up. The front panel is sitting there trying to connect to it, and it's not happening. So how are we actually going to troubleshoot this? Well, I was quite intrigued by this roll call network here, and it's shown as being connected to a PC, and I wondered if this might be something like Ethernet, because if it is, that's a possible easy way we can pry into this and see what's actually going on in there. Now there is actually another drawing on the rear here, which is even more interesting. If we have a look at this diagram here, we have something that looks a bit like 10 base 2. Remember the thin Ethernet, with some differences though. It's shown as being 75 ohm, and somewhere here it says that the bit rate is 2.5 megabits, which, yeah, there it is there, which obviously wouldn't be 10 base 2, that'd be 10. So I wondered if that's what they've done. They've taken ordinary thin Ethernet and just run it at 1/4 the clock speed at 75 ohms, which means that would go over a television video circuit just fine, which would be quite interesting. So potentially we could cobble together some kind of adapter that possibly could use to pry into this. However, I actually had a look at the chips which are used inside the unit, and what I found is that this is actually ArcNet. ArcNet. So this is one of the predecessor technologies to Ethernet. It does have a similar physical topology, but yeah, it's very, very different. Now, you might be thinking, well, why would they use something so antiquated? Well, this is actually a pretty ideal protocol to be using for this sort of application. ArcNet is a token passing system, so it's a lot more reliable, it's deterministic, it's simpler, 8-bit addresses, so yeah, that makes sense. Fortunately, it means that it's, this trying to pry in through this network interface, this might be pretty difficult. I haven't actually researched this, but I don't think putting together a kind of protocol sniffing arrangement for ArcNet would be particularly easy. So we're not going to be doing that. But yeah, what we'll do is open it up and actually see physically what's actually inside of here. So upon taking off the lid, this is what I'm first presented with. Now this piece of equipment, despite having a lot of analog connections on the rear of it, well, we can see that actually this is an intensely digital item. So what they're basically doing is converting from analog to digital immediately at the perimeter of the unit, and they're just doing everything in the digital domain, which for a piece of equipment of this era, and certainly what it does, that's completely to be expected. And yeah, certainly for, you know, analog people, although there will be a lot of amazing engineering in this thing, it's a lot harder to appreciate when it's all buried inside these magic chips. So how are we actually going to troubleshoot this thing? Well, first and foremost, we'll do the basic checks which you should do on any piece of equipment that you're trying to repair, and that is we need to make sure that the power supply is good, and we also need to make sure that all of the interconnections between all the various parts inside this thing are in a good state and clean and all of that. And certainly my experience of repairing this kind of stuff in the past is that most of the time, yeah, that's usually the kind of thing that kills it. Boards like this tend to be very reliable and they don't really fail all that often. Now that having been said, there is a possibility we could have a failure in a big scary digital board like this. Now there's good news and bad news here. Now the bad news is that, well, I don't know for certain, but this looks to be of the kind of era where it's very unlikely that any detailed service information will have ever been published. I could be wrong about that, but yeah, I mean, I doubt it, because even if it was, what would you do with it? It's just a lot of digital stuff. You really need to be getting into the software to actually debug this stuff. And that's the good news, is that PCBs like this, certainly in their day, are very valuable. They're, you know, probably 8 or 10 layers. There's a lot of expensive chips on here. They were worth repairing, and there were ways of diagnosing them, particularly through the software. And it's possible that those mechanisms are in here, and we might be able to get at them and use them to help us. But I'm hoping it won't come to that, because if it does, this potentially could be quite a big project. So let's. I think I'm just going to start off with just cleaning up all the connections and seeing if that makes any difference. Alright, so I've just gotten all excited taking this thing apart, and already there's been a few surprises about how it's actually built. Now, the first and the biggest one is that this big PCB here, this is actually the only major assembly inside the unit. I was expecting to find another similar PCB underneath, you know, but yeah, for what it does, they got it all done in just this one board. Yeah, that's pretty cool. I also unnecessarily removed these connector modules out of the back. I thought that would be necessary to get them out, but it's not. This board actually slides out through the front panel quite nicely, actually. But if you are taking these modules out, just one gotcha, the module at this end is a double height. Yeah, it's double height, as you can see, so you've got to take the whole thing out in one piece, even though it looks like they're separate. They're not, so yeah, whereas the rest of them look like that. But yeah, anyway. In terms of how it's actually all connected together, you're first like, what the heck? How is this board even connected to the other stuff? So what seems to be going on is that the board goes in and plugs into these modules, which have these connectors on them, which then plug onto the backplane. So it actually gets its connection to the backplane through these modules, which is just bizarre. I've never seen anything like that. But I suppose it makes the unit very serviceable, because yeah, when you're taking this board out, there's actually nothing attached to it. Now anyway, I've taken this apart so I can clean all the connectors, but of course I've gotten very distracted by the details of it here. So it turns out the main, I think the main system CPU is this one here. This is a C166 architecture microcontroller. I've never even heard of it. This is some Siemens thing, very obscure. But if we do get into trying to debug the startup of it, this is going to be where we'll start. And I see we've got a little connector here, so this is probably the thing that the repair technicians hooked up their stuff to and did whatever they did. So anyway, this is off topic for the time being. So let's just get through and clean all these connectors up. Alright, so I've been around, given it a nice healthy dose of deoxit, and we've also removed some lovely black apparatus room dust. Well, some of it anyway. Now, a thing to note about this sort of equipment is the deoxit treatment. You don't really win very often from doing that, because the connectors they use in these sorts of products tend to be high quality, gold plated. They don't oxidize. But that having been said, I have seen a few examples of connectors going bad, so it's always worth trying. So yeah, let's switch it back on and see if this actually made any difference. Well, I've been sitting here for about 5 minutes now, and it hasn't booted up. So let's just quickly check the power supply and make sure that's actually producing some nice looking voltages. Alright, so first of all, let's check our plus 7.5 volt rail. Looks good. Not really any ripple. And the other one is the minus 7.5 volts, and that's actually all this power supply produces. It's kind of unusual voltages. Minus 7.7, a little bit high, but yeah, it's fine. And yeah, no ripple on it. So yeah, I think that power supply is good. This looks pretty clean, so it must be something else. Now we do actually have various blinky LEDs here, so I think it might be worth getting out the other unit and see if we can see any differences in the blinkiness, which potentially might give us a clue about where to look next. So this one here is our good unit. We'll switch it on. Now straight away I did actually notice an immediate difference. Now annoyingly, this one is an older design, it has less LEDs, so those I2C LEDs we saw on the other one, it's just a blank there. But we do have the net LEDs, which that's the roll net on the other units, and what I can see on this one is that both of them are blinking, whereas on the other one, only one of them is blinking, only the green one. We never see the orange one blinking, so that would indicate that on this unit we do have a two-way communication going on, but it's only happening in one direction on the other unit, but which direction is it going in? Now interestingly, these LEDs here are the same as the other unit. This orange one here I'm particularly interested in. It's not marked on the silkscreen, but what I think that is a heartbeat indicator. So the operating system is probably toggling that on every X many passes through its idle loop, and this would indicate to software engineers that the code is running, it's doing stuff, as opposed to locked up, having been locked up because it's crashed. And on both units it's blinking, so that might mean that the baseboard has actually booted on the other unit, and we've just got to break down communication, or it could actually be the front panel that's failed. So who knows? I think maybe the next thing to try would be to see if we can swap over the front panels and see what happens. So basically I've just stacked the two units on top of each other, and I've just crossed over the ribbon cables for the front panels. I love that it's so easy to do this. I have no idea whether or not they're actually going to be compatible with each other, but let's switch it on and try it. So first we'll turn on the good unit, which is the bottom one, with the bad unit's front panel. Let's see what that does. Might as well just turn both of them on actually. So I've got them both plugged in. Hey, look at that. So our unit with the our bad unit has yeah, the front panel's actually worked with the good units, but the inverse hasn't worked, so this one is not connecting to the baseboard on the bad unit. So I think we're narrowing this down. It's not the front panel, it's either the control gateway or it's something on the baseboard, or possibly still some kind of interconnection. But yeah, this is going to need a bit more troubleshooting to get the bottom of, and I think this possibly is going to be potentially a bit of a challenging repair. But anyway, let's push on. So for my next experiment, I've now actually swapped over the baseboards. So we've got the good baseboard in the bad unit and vice versa. And once again, I'm assuming that they're compatible. Hopefully we don't get any smoke. So let's switch these on and see what happens. Who's going to boot up, if anybody? Oh, that's interesting. So our bottom unit, which contains the bad, supposedly bad baseboard, has booted, which is actually quite reassuring. Our top unit, which contains the good baseboard, no, hasn't booted. Well, that's actually quite reassuring, because we basically, I think, could we safely assume maybe the problem is in the control gateway, which sits behind the front panel here and not in the baseboard? I'm certainly hoping that's the case, because the control gateway, that looks like something I can possibly reasonably easily deal with, because whereas the baseboard, oh man, I don't want to be having to find a fault on that. So yeah, maybe we just get this control gateway out of here and have a look at it, because that appears to be, certainly from this experiment, that appears to be indicating that it's faulty. Well, this is our control gateway interface, and yeah, straight away, ugh, yuck, it's a real mess. The positioning of it is rather unfortunate. It sits right in front of the power supply, so has a lot of rather foul air dragged past it, and it's possible the reason this has failed is just the sheer filthiness of it. So yeah, we're definitely going to give this a clean up. Now, in terms of what this actually does, now that piece of paper we looked at before suggests that it's just a switching device, so it switches the control of the baseboard between either the front panel or the roll net interface, which is that coaxial connection which is on the rear of the unit. And certainly it does look rather complicated for serving that purpose. However, I noticed that there's an ArcNet PHY on here. There's a physical interface chip. So what this is suggesting is that the baseboard and the front panel don't communicate with each other via ArcNet, even though that address on the front panel kind of looks like they might be, but yeah, I don't think so. So the ArcNet starts on this board. So this board's probably more of a network interface card than it is a switching device. So yeah, looks like we've got another one of those obscure Siemens microcontrollers there. And we got a Flex FPGA there, Altera 5-volt one. Hands up if you remember Altera Max 2. And yeah, bonus points if you ever ran it on Windows 3.1. Yeah, I'm not that old myself, but yeah, and we also got some SRAMs and some flash which it runs out of, and this connector which appears on the baseboard, this time actually labeled download. So yeah, that's our software programming header, not a debugging header, but still. potentially useful if you were a service technician. Anyway, so let's clean this up and see if it makes any difference. Well, there we go. That's looking quite a lot better. Let's put it back in the units and see what happens. It still isn't booting. Now, I have actually seen it boot once. I think the very first time when I received this, I powered it on. It did actually boot up once, so it's not totally dead. But yeah, it's not happy, is it? There must be a bit more to it than filthiness. I think the next thing to do is get the gateway out of the other unit, put it in here, and see whether or not it boots. And that would eliminate the wiring harness and the backplane, and then we really know it's this gateway. Let's go and do that now. So that's the gateway out of the old unit there, and look at it, it's a completely different design. But yeah, from what I've seen so far, the parts in these things are fabulously interchangeable, even across different generations. So yeah, maybe this will actually work. Let's put it in there and try it out. Haha, look at that, it works. So the old gateway in this unit works fine. So I think at this point it's pretty safe to say that the gateway of the newer unit is bad, and that's really where we have to focus from now on. So here's our two control gateways. Here's the older good one, and this is the newer bad one. So the question is, what can we look at next in terms of actually trying to figure out what's actually wrong with this thing? The only thing I can think of right now is to check whether or not this FPGA actually ever receives any code. Now this is an SRAM FPGA, which means that the program for it is not stored in the chip. It's stored somewhere else. Typically that would be a configuration memory, but I don't see anything that looks like a configuration memory on here. So it's possible that this microcontroller here uploads the code into this when it first boots up. So we can probably observe that process in action, and that might give us some idea of how working or how functional this thing actually is. So let's hook up the scope to it and see if we can see anything going into it. So I've just got the scope probe on the pin which the code is sent into when it powers on and gets programmed. So we'll just power it on right now. Have a look. Yeah, look at that. That was a burst of data, and there was another one. So it looks like the Siemens microcontroller is uploading the code into the FPGA, which would indicate that it's booting, it's doing stuff. So yeah, this is getting a bit more difficult now. So I've been experimenting a little bit off camera because I'm doing all sorts of silly things right now, and it'd be quite boring to watch it all. But one of the things I noticed is that when I squeezed on these SRAM chips, it actually booted up, it worked. So this thing is definitely partially working. I tried a few more times. I haven't been able to get it to happen again on camera, but because dead SRAM chips are such a common cause of failure in vintage equipment, I think I'm just going to have a look in my junk box and see if I've got anything I can replace those with here and now, just on the off chance that that is the problem. Well, I've replaced those two SRAM chips and it didn't make any difference, which is a bit of a disappointment because that would have been amazing if that had just fixed it. Now, I've actually spent a few hours studying this board off camera because, as I said, this is becoming quite a detailed repair and we can't film all of it. It's just a bit too much for me to try and narrate everything, and probably a bit too much for you to watch. So what I've learned so far about this board is that these two connections here, which are the only ones that are required for this type of operations, on the one which goes to the front panel you have power, and there's some sort of possibly differential data connection, and then there's an I2C connection on this connector which goes to the baseboard. Also on this connector is the ArcNet data signal, which is just one conductor, and that goes to the BNC connector on the rear. So what I'm basically doing right now is studying these interfaces and seeing what's actually happening to see if we can narrow down the problem. Now, one of the things that I noticed which was interesting is that these two LEDs here are I2C status LEDs, so they are literally buffered straight off to the SDA and SCL, so you can actually see what's going on the bus. When the board works, I see a different pattern on those LEDs compared to what I see when it fails. So the first thing I wanted to have a look at is whether or not the I2C is good, whether or not the bus is clean and communicating properly. So I've gone out this little protocol analyzer here, and we're just going to fire that up and see what it actually looks like. Now initially we do see some corrupt transactions, but that's probably to be expected because it's still initializing. Those pins are in an unknown state. But eventually we do actually start seeing some traffic. And looking at the trace there, there's no errors. I mean, we can see data going through there just fine. If there was a problem with the I2C communication, we would see some red text there indicating that there was some kind of corruption going on, and there isn't. So it looks like the CPU on this card is executing because it is the I2C master, and the communication is good. So I think we can rule out the I2C. Now the next thing to check is the signal coming in from the front panel. I beeped it out just before, and it looks like the only two things on here which aren't power are these two pins. So let's just have a look what is going on here. So yeah, we've got something there on that one, and that looks almost like a complement of what we were just looking at. But interesting, the scope says that this is 2.5 megahertz. Now that's what we would expect if this were ArcNet. So I did suspect that the front panel may be using ArcNet to communicate with this gateway, and certainly that does appear to be agreeing with that theory. Now if that's the case, those two pins there really only can be going to the ArcNet PHY here, which would be detokenizing that data, and presumably it would then go into that microcontroller there, because there's nothing else on this board which really would be able to cope with that. So it must be that, because I know I did beep out before that those are going to this FPGA, and then maybe they get switched into this ArcNet PHY. So I'm going to go and have a look at the pinout of this chip here and see if we can see anything going into it. According to the datasheet, there's 3 pins we want to look at here. There's 2 transmit pins and a receive pin. Now I think what happens is that the front panel, although not physically ArcNet, is using the same protocol, or maybe like a TTL version of it, which runs through this FPGA, which then gets connected straight onto this chip here. And the datasheet suggests that in normal ArcNet usage there would be some analog circuitry after this chip, which maybe this stuff under here, which would then go onto the physical ArcNet interface on the rear. But I think that when it's in this kind of front panel mode, it bypasses all of that and it just gets connected straight through. So let's have a look at these pins and see if there's anything going on. So this is one of the transmit pins. Nothing. And once again, nothing. And this is the receive. Nothing. Huh. Yeah, that doesn't look right. I mean, from what I saw in the manual, this interface should always be active, so we should always be seeing tokens on the interface, on the external interface of that chip. But yeah, there's nothing going on, which doesn't look good. I think I'm just going to get out that other gateway and see what's going on with that. So we've got the old gateway back in here, and of course it works perfectly. And so I'm just going to check those pins on the ArcNet PHY to see whether or not we have anything. So this one here was the transmit pins. Oh, look at that. Yeah, that looks rather familiar, doesn't it? That's the same, very similar to that signal we saw coming from the front panel. And the other transmit pin, get my scope in here. Yeah, let's change my angle of attack here. It's a bit tricky to get that down there. I don't seem to have anything on that one. But there's the receive pin. Yeah, yeah, that's what I would expect. We should always see tokens. So if we check the front panel, not actually triggering very nicely on that one. Let me change my trigger. Yeah, it does look very similar. I don't know sure that the scope is not triggering as well as it was before, but yeah, it does looks pretty similar. Huh. Well, I think that's probably a red flag there. As I expected, the ArcNet file should always be doing something, and it is on the good gateway, but it's totally inactive on the bad one. So yeah, there's the problem. But why is it not working? Oh, I don't know. So what do we do next? Well, we now know that there is a problem with our ArcNet interface. Ideally, what I would do is to try and debug this with a logic analyzer. So what we would do is we would look at the transactions between the microcontroller and this fire chip here to give us some kind of clue what's actually going on, because we can look at the datasheet for this and we can study how it's actually supposed to be communicated with, and we might be able to see some clues in the exchanges between these two chips as to what's actually wrong here. And that's something that the engineers who originally designed this board would have had to have done back in the day. So we have to ask the question, well, how did they actually do that? Could we do that here? I think the answer is unfortunately no. Now, there is actually a variation of this board for their IQ chassis products, which has Mach1 connectors on it. So yeah, that was how they debugged it. And this one here would have just been a variation of a known working design, which was never debugged, which is a real pain. To get that sort of access on this board, I would have to solder on a whole lot of fly leads. It would take hours, and I really don't want to do that if I can avoid it. Now, what he said we should do is try to connect to this unit through the RS422 interface, which is that's on this connector here, which goes out to a 9-pin D-sub on the rear. And by doing that, we would be able to establish that this microcontroller is in a good state and working. I mean, I kind of feel like we're already fairly confident that it works. However, I suppose if we can get in here through RS422, which wouldn't involve any of the ArcNet circuitry, that would give us that extra bit of confidence that at least the control part of this board is actually working. Now, the chap who owns this equipment actually supplied me with this USB to RS422 and RS485 adapter, but he said that he's never been able to get this to work. Now, I'm not certain that this has actually been wired correctly myself, so I think what we'll do is go and make up another cable to replace this one, which we're confident has been wired correctly. Now, this equipment supposedly works with either RS422 or RS485, and the previous cable was intended to be RS485, which didn't work. I'm sure it could work, but as it didn't, I've gone for RS422 here, and we'll see whether or not that works. The software you use to communicate with these boxes with is called Roll Call. I've been given an installer for it. From the screenshots I saw, it looked pretty old. The interface would suggest that it's been built for Windows NT 3.51. Which is from the 90s, so I decided to get out this XP laptop, which should be fine. So at the moment we're just running with the unit switched off, and we can see the PC is transmitting some stuff, so let's switch it on and see if we get anything back. Nothing yet. Oh dear. Hey, we got an RX. So we got two-way communication. So according to the manual, I can just click this and I should be able to see if there's anything detected. Hey, we've got a Mach1. Right, so what we should be able to do now is go into the control panel and actually connect to it. Oh, this is looking good. Hey, we're in. It looks like our RS422 is working on that bad gateway, which Well, I'm going to cut it there because I've already filmed 35 minutes of footage and I think that's enough for the time being. Me personally, I now have to go and think about how I'm actually going to attack the next part of this repair. If it's going to start costing money to buy expensive components, then obviously we'll need to consider the owner and whether or not he wants to spend that, or if he's just happy to run it with the roll call RS-422 interface, for example. And also, in the previous repair video, I ended up replacing a bunch of components blindly, which wasn't really very satisfying. I'd really like to really pinpoint the exact problem this time rather than just replacing stuff willy-nilly. So yeah, that's all for now, and thanks for watching, and hopefully we'll be back with the rest of this at some point in the coming weeks.